So here we are going to start our today's class, that is algorithm design and techniques topics. These two topics we will study today. One is matrix multiplication and exponential evaluation, right? So first of all we have to understand what is matrix. So matrix is basically which has rows and columns in which we are storing our data in rows and columns forms. So here we have stored our data in rows and columns form. So here I am having 3 rows and 3 columns. So first number denote rows, the next number denotes columns. So here I have created 3 by 3 matrix. So in this way we can have n by n matrix, right? So if I have equal number of rows and equal number of columns, then we call it as a square matrix, right? So now we are moving further. Now if I want to do this task, that I want to suppose, because our topic is matrix multiplication, so I want to multiply the two matrices. So here I have taken two matrices of size 2 by 2, right? So if I want to multiply this mathematically, you know this thing, that how we can multiply two matrix. This row and this column is multiplied, then this row and the next column is multiplied. So in this way we will get the result. So here 1 is multiplied with 5, 2 is multiplied with 7, right? And in the next value of the product matrix is achieved 1 into 6 plus 2 into 8, right? So hope you have understood this general way of getting these values. Then you add these 5 plus 14, you will get this 19, and similarly you will get the other values. So how we will write the algorithm for doing this matrix multiplication? So first of all I have to find a general formula of multiplication. So first of all I have to know about or learn about how the matrix is stored. So matrix is basically denoted by row number 0 and row number 1, and columns are denoted by column number 0, column number 1. So if I say this is my row number 0 and this is column number 0, so this cell becomes 0 0, where these are getting intersected. Here remember this thing, that row number comes initially. This is my row number, this is column number. So this is in row 0 and this is in column 1. So I will say 0 1. So in this way I have written this thing. Now I have to multiply this matrix with this. So let us find first of all this one in relation with this process that I have told you. This cell is A00, this is getting multiplied with B00. This is A01 and this is multiplied with B10. So we have written here C00 is achieved by A00 multiplied with B00 and A01 multiplied with B10. So in this we have written all these 4 terms and their corresponding formula. Now I have to find a general formula where I can write these numbers as I and j. So if I can see my I is going from 0 to 1 and j is also going from 0 1. So obviously this I, if I is 0, it is running, j loop is running inside it. For each there is 0 and 1. So that means j loop is going inside of I loop. Now here I have to see where I can place I and j. So here if it is 0 and 0, if I write this as I and this as j, right? Same here if I write here I and j. Now is it valid here? This is 0 1. So here also should be 0 1, but it is not. That means this number is different. This is not j. So I cannot write here this is j, but this is I. You can see here this is matching with our I. This is matching with our I. This is also matching with I, right? No, this is not matching with I, because in this you can compare this. Here it is 0, here it is 1. So these numbers I can write I. Here I can write this as j, because see here 0 0, here it is 1 1. Now here 0 0 and here 0 1 and 1. That means this is my j, this is my I, but the middle ones are some other variable and both are same. Here 1 1, here 0 0. That means my general formula will be including some other third variable, and for first time it is 0 and for the next time that variable is 1. That means that can be k, which is firstly 0 and then 1. So you can see here we have made a loop of I that is going from 0 to n minus 1. N is my matrix of 2 by 2, so my loop is going from 0 to 1. Then inside loop of j is also going from 0 to 1. And as I told you, there is an introduction of third variable because here k and k is same, so it becomes aik into pkj. Because I need not to write it twice here because same formula is there. So I am just saying, first of all it will find k, for k0 it will find the value and it will store in Cij. Then for k equal to 1 it will find again the value and it will store in the previous Cij. So for that I have to initialize Cij with a previous value. So first initial value I have taken 0, then ai0 into b0 and something will be added to it. Then for k equals to 1, the old value will be added with ai1 into b1j. Hope you have understood this matrix multiplication procedure. This is the algorithm, and for this we have written here input. What input we require? We require two by two matrices, that is A and B, and what will be the output of this? We will get a product matrix C that will hold the product of this. So we have created a function which is taking input of two-dimensional arrays 2. Third two-dimensional array is not initialized, but these are to initialize, and n is a number of that is a size of matrix, order of matrix. So the order of matrix is n by n, so this n is denoted here, right? So now what we have to find? We have to find the complexity, and it is very easy. If you have understood this program, you can easily find the complexity. Initially also we have found that if this loop is running how many times? N times. This is running n times, this is running n times. So for each n times it will run inside n times. So how many times it will run? N into n, right? How many times this loop will run? For example, I have shown you here, if this is 0, so for this 0, how many times j is introducing? 2 times. For 1 0 it is getting 2, for 1 then again 2. So for 2 values again j will be running twice. I mean to say that if my outside loop is containing n terms, so inside loop will run for each of the I values. For example, if I is equal to 1, so for 1 j will run how many times? N times. Again for I equal to 2, it will run n times. So how many times my loop is getting run? N into n, because outside I loop is n times, inside loop is n times, so n into n times it will run. But suppose j is having again one more loop that is again running n times, n into n will be our complexity, right? Here I have neglected these things because they are taking constant time, but they are multiplied with this variable. For example, if I say this assignment operation is done how many times? Whenever this loop will run, and this loop will run how many times? N square. So I can say Cn square. Now here add and multiply, suppose I say C2 time, C2 second it takes. So C2 into how many times? On cube, n cube, right? So C2 n cube plus Cn square. So total complexity is highest when we take the highest one, what we get? N cube. So here we have told all these things that it is taking constant time, and due to the inner loop the total complexity is big of n cube, right? I have understood what I want to say here, because here whatever I have told you is written here, right? So now let us move to the next topic, that is exponent evaluation. Okay, now we will learn about exponent evaluation methods. Basically, what is exponent, that we will study first, but there are two methods which have been introduced to make the evaluation of the exponent faster, right? So here, what is exponent, that you study about power. So what we have read earlier is same, that has named now as exponent. So if I say x raised to power a, so x is termed as a base, and a, that is basically a power of x, is termed as exponent. So we have, if I say evaluating exponent, so I have to find this value. So what is the value of x raised to power 4? It will be x into x into x into x. So this is the evaluation of this expression. But if I say I am evaluating this, or I am finding the power of x raised to power a. So for this, if I write a program, so how many times I have to multiply this x? So for example, I have to, if this is raised to power 4, so I have to multiply this x how many times? How many multiplication operations are there? 3. That means I have to make a loop that should go from 1 to n minus 1, or a minus 1, and then it should multiply x with the previous value of result. So, but here we have found that initially it is giving 3 multiplication, but if I use any of these exponential methods, my work is easier, so and faster. So we will learn this two methods, left to right binary and right to left. Now what is this? For this, what is our requirement? Our requirement is that I require this exponent in the form of binary. So you should know how to convert a decimal number into binary number. So if the value is here 5, so I have to calculate its binary initially for the fast computation or fast evaluation of exponent, right? So here we will learn about this method, left to right binary method, and then we will study about the right to left. Both are the different algorithms. In left to right we are going, uh, in the binary representation we are moving from left to right, that's why it is termed as left to right, and in the binary number we are moving from right to left, that's why it is known as right to left binary method. Now we will understand this. For this I'm just moving to directly to the program. So what we are doing, we are given the input that I have to find the a raised to power n, and a binary string is given which is containing uh, binary numbers of this n power, means it is containing the representation of n. For example, if n is 5, what will be the binary of n? 5, 1, 0, 1. So array will contain 1, 0 and 1, right? So I have to find the value of a raised to power n. For that I have given s is the length of this array, or suppose if I say 5 is represented as binary numbers. So what will be the length? Length will be 3. So I am storing the length of the array in S, right? So here what we are doing, we are initially taking that my result is containing the value A. Then I told you our loop should go from the binary digit, because this method is what, left to right. So for that, if your binary is containing 1 0 1 1, you are moving from left to right, means you are taking which position, because our position in array start from 0, so this is highest position. So here my loop should go from s minus 2 to 0. You will understand by with the help of example of how I am saying this. Let us take an example for making a better understanding of program. Let me take a so here my n is 5 and the binary of this 5 is 101. So length of string is 3 because this binary numbers are 3. So store this array or the binary numbers in array. So array size will become as that is a3. So initially I am taking result equals to a. So whatever the value of a will be stored here. Now first time when this loop will run. So what will be the value of I? S is 3, 3 minus 2, 1. That means my loop will go from 1 to 0. Right? That's what I told you. It is coming from left to right. So one will high value will come, then low value will come. So here I is 1. So what is our formula? It will go inside. Result will be result into result. Result value is a. It will become a into a. So it will rise to result will become a square. Then it will check the condition. If ai is 1, then result again a will be multiplied, right? So in every iteration it is checking. Firstly it is computing result, then it is checking ai. Ai means this array. Wherever there is 1, then again one more a will be multiplied here because I have started from here from one position. I have not started from two position. So this is one position. So from one position, well, what is ai value? It is not equal to 1. So a will not be multiplied because I have said if ai is 1, then multiply a, else not, it will not multiply. Now again the loop will go on, it will come to 0. Now what will be the result? Result will be the previous result, so it will become a square into a square. So you can say here that I am utilizing the previous result. I need not to find this a square again, right? So this is computing this a square into a square. Now again it will check if a0 is 1. Now my a0 is 1 here, so it is 1, so result will be multiplied again with a. So you can see that here I have come up with a5. Now how many multiplication operations I have computed, right? I have done 1, 2 and 3. Only 3 times I have multiplied, right? So now if I take the case when Now let me take the case when I have to brute force, means I have to apply all the multiplications and I am not utilizing the previous stored result, right? You can see here a into a. Now you are multiplying again a. Now you can see here it could have been made that this value here and this value here. So this could have been utilized here. So but what it is doing, it is just multiplying again a, not utilizing the previous result. That is the main drawback of this approach. So here the loop is going from I equals to 1 to n minus 1 and result is multiplied with a, right? So how many iterations will be there? For 5. How many multiplications are there? 4. So the loop, how many times a should be multiplied? 4 times. But with this approach, how many times I have to multiply? 3 times. So you can clearly see that the multiplication or number of times the multiplication has been reduced, right? So now the next example that I need to take is with a raised to power 17. But for this I just want you to do it first and then check your value by this. But uh, pause here and just compute your value. But here I am continuing this video, so I am just explaining you this example here. So here what is done here? Here 17. For 17 I have to compute the binary, so I have computed the binary and then is my 17. What is the length of the binary? 5. So S will be containing 5 and result will contain A initially. So my loop will start from which position? 0, 1, 2, 3, 4. You know the loop start with S minus, you remember, S minus 2 to 0. So what is the length? 5. 5 minus 2 is 3. That means loop will go from 3 to 0. So result will be A into A. A square has been computed. Again it will check the position of this value. If A3, 0, 1, 2, 3. If this is 1, again A will be multiplied. Now this is not 1, so A will not be multiplied with the result. Now iteration 2, because at the next time the I will be decremented. Now what will be the result? Now it will utilize the previous result and multiply the previous result with the previous result and it will become A4. Now again it will check if this is 1. If this is not 1, then it will not multiply 8. Now it will reduce again I1. Now it will multiply the previous one with the previous result and it will become A8. Again it will check if it is 1, it is not 1. Now the next step is, final step is I equals to 0. Now you can see here A to power 8 is multiplied with to power 8 and we have got A16. Now here it will check this position is 1. This position is 1 means result will be multiplied with A. So I have got here A17. Now you can clearly see how many multiplication I have applied. 1, 2, 3, 4 and 5. See, to find this A raised to power 17, you have done only 5 multiplication. So how much benefit this is giving to you, right? So approximately reduced to half, less than half, right? So here you can see that if I apply here total, if I done here, I could have done here 16 multiplications, right? Because if A raised to power 17 means how many multiplications should have done? 16. That is the first case scenario, right? But here, what I am doing here, I am doing 5 multiplications. So in this, I have achieved my better efficiency by using left to right binary exponential method, right? So what is the complexity analysis that we can do here? So here we can see that if my n is my exponent and s is number of bits required to represent n, the maximum value of n will be what? Suppose my all are 1. 1 means what will be the value? 7. So what is the maximum value to represent this is 2 raised to power s. Okay. So in this way I can represent it, take log n both sides, because why? Because my time complexity, as obviously how we find the time by viewing this algorithm, my loop is running how many times? Simply because we are saying this is C1 and this is C2 and this is C3. All these are constant, but what about this loop? Loop introduce some variables, so this loop is dependent on S. So I must say that my complexity is dependent on S. So I have written here that the complexity is dependent on S, but I have to give it in the terms of n. So I have to compute this and S value in terms of n. So what I did, I know n is equal to 2 raised to power s. So take log n both sides. So you can see here, I have taken an example to make you understand this. Suppose s is 3. So if s is 3 means my binary digits for representing my number is 3. So if I take my binary number to represent my number n is 7 suppose. So this is the binary code of this. So I can write this as 8 minus 1, right? What is 8? 2 raised to power 3. So I can write like this. So if I ignore this part, because neglecting this, if this is very high, so I can write n equals to 2 to power s, because this s is 3. So this formula is resembling here that the maximum value will be n equals to 2 की power s approximately. So now take log both sides. So what I will get, log with base 2, right? So here just ignore this one, remove this one, so take log. So 3 will come forward and it will become log 2 2. So you know about the formula of log. If you have the same base and same this value, it will be cancelled out, it will become 1. So we get log 2n is equal to 3. And what is 3? 3 is our s. So got the formula that s equals to log 2n. That is my complexity of this algorithm as O log 2n. Right? So now we'll take the another approach, that is right to left exponential method. It is also again using the same approach. I'm again moving to the algorithm, and one thing you have to remember this, what is pseudocode? Pseudocode is just the representation of this algorithm or the program in the form of words, right? So if you are understanding the algorithm, you can write the pseudocode in the form of words. So I'm making you understand the algorithm. So what is the requirement of the algorithm? Algorithm again is taking the same thing like previous left to right was taking. Only thing is changes. Here we will move from right to left, right? So right, I have 0, then 1, then 2, like this, right? So obviously I will take the example first so that I can make you understand easily. Then here an example to find a to power 5. So I am having n equals to 5, right? It's binary again, like you have done in the previous one, because this is binary. If binary representation of the power is helping us to evaluate it fastly. So what is the length? Length of the binary is 3. So again, what I have done, I have taken an x variable here. Instead of result, I have taken one more variable x and I have stored the value of a inside that. Now we have checked here. Suppose this is my a0. Obviously I am moving from now right to left. So I will check here, if a0 is 1, then result is a. Now let me come here. Loop is starting from here, but I have to do this step initially for a0 part. So if I have a0 is 1, then my is a, else result is 1. Initially for initializing result, I have to check this condition. That's why, because I have done this for 0, that's why I have made here loop from 1. Because this is an incrementing loop, you are moving from right to left, so you are increasing from 1 to s minus 1, because total size is s, so you will move in the binary array from 1 to s minus 1, right? And for each iteration, what you have to compute, you have to compute x, and you have to check condition. If the value is 1 in the array, then multiply x once more, right? So see here, so I have taken the initialization step. A0 is 1 here, so result is A. Now what I have to do, I have to move from I equals to 1, because I have to move the iteration from 1 and 2, because my loop is going, my array is containing the elements 0, 1 and 2, right? So for 1, what I have to multiply x with x, and x is containing a, so this will become a into a, right? Now it will check whether it is 1. It is 1 here, no. So result is unchanged because ai is not equal to 1. Now move to the next. If I is equal to 2, so at I equal to 2, our value will become x equals to x into x, right? So according to our algorithm, right? So as we have done the first iteration, at I equal to 1, again x is multiplied by x and the condition is checked. Same here, x is multiplied with x and then the condition is checked at a2 position. As I am having 1, you can see here, this is 0 position, this is 1 and this is 2. So at this position, as you are having 1, so what is the algorithm says, that your result will be multiplied with x. So here, when I multiplied x with x, my initial x at this position has become already a into a, right? But the result has not changed because ai was not 1. At one position I was having 0. So this condition was not true, so result didn't change. But x value has already changed. So when I multiplied x with x, so a square is multiplied with a square. And what about condition? As condition is also true, so result will be multiplied with x. So result is containing a, and this is containing 4 times a, so 4 times a will be multiplied with a, so this will become a5. So you can see how many multiplications I have done in this procedure. Here 1, 2, and here I have 3. So total 3 multiplications I have done in this procedure. Now we can take the another example where our uh, exponent is 17. So I have to find its binary. Then obviously this is right to left method. So here I have to move from 0 to n minus 1 position, right? So I have to find first of all the length of string. Length of string is 5, so it will be stored in S. And I have to create an array which will contain all these binary numbers. Then I have to move one by one, and first of all, according to the algorithm, we will check a0. A0 is 1, so result will contain a. Now the loop will go from 1 to n minus 1. So first of all, I will be equal to 1. So at this position, x will be multiplied with x into x, and x contain initially a. So a into a, and it will become a square. Now it will be checked whether the condition is having 1. If it contains 1, then the result will be multiplied with, as you know, I have shown you the previous formula that we will multiply result with the x. So now as it is not there, as 1 is not there, so this will not be applied here. So I will be incremented, I will become 2. Now what will be done? X will be again found. That x will become x into x. The old x is a square, so a square into a square, it will give a4. Again, a2 position is not having 1, so the next condition is not satisfied, so it will not multiply the result with x. Again I will be incremented, and the same procedure will be followed. The old x will be multiplied with the old x, so I am using the previous result here, right? So it will give a8. Again the condition is false, but when we will come to the fourth iteration, x into x will be there, but we are having at a4 position, we are having 1, so it will do result into x. So result is my a, so a into a16, because x is now a16, so it will give me a17. So we will return the result. So you have understood what it is doing. Now how many multiplications I have done in finding a17? Here 1, 2, 3, 4, and here 5. So you can see how many multiplications have been reduced to 5 multiplications only. If I would have been doing by the brute force, I have to multiply 17 a's together. So for that, how many multiplication symbols I require? 16. That means I need to multiply n minus 1 times. But here, my loop or my complexity is dependent on which variable? S. So again, similar way that we did for left to right, here also the complexity is again dependent on s, so it is O log 2n. So you can see here in the brute force it would have been 16 multiplications, but due to right to left binary exponential method, your number of multiplication has been reduced to almost less than half, that is log of n. So you can see how much efficient this code is there. So this is the complexity that is dependent on s, and s is our log to n, and it can be explained in a similar way that we did for the left to right, right? So we have completed our this exponential method. Enjoy learning, and thank you for watching this.